Hi and welcome to our project demonstration. My name is Roman and I'm the part of this course project. Today we're excited to introduce you to NecroRun. At its core, NecroRun is a fast-paced roguelike game. If you're familiar with this genre, you know exactly what it means. High stakes and endless replayability. In NecroRun, every single run is unique. The arenas, the enemies you face, and the challenges are procedurally generated. When your character dies, you lose your current progress and have to start all over again. This forces players to learn from their mistakes, adapt, and master the combat system, rather than just memorizing the map. No two runs are ever the same, which makes it that interesting. To show you how we built this project, we structured our video. First, we will talk about the most noticeable thing, the visuals. After that, we will dive into controls, the sounds, because it's the next thing the player interacts with. Then we will look under the hood at the complex level structure and enemy spawns. And finally, we will cover the overall game creation process. Since the very first thing a player notices is the visual style, I will start by sharing my part of the work. I modeled the main character and the main enemy entities from scratch in Blender and set up their skeletal rigs for animation. For the arenas, my focus was on level blocking, designing the layout with simple shapes to make sure the fast-paced gameplay flows perfectly. Once the blocking was done, we utilized some great environment assets from the internet to efficiently build up the dark, oppressive atmosphere out of our world. After finishing the animation cycles in Blender, I imported everything into Unity. To bring these models to life, I worked with Unity Animator to build complex state machines. In roguelike, combat must feel perfectly responsive. My goal was to make sure that every attack, dash, and movement feels fluid and gives the player clear visual feedback during those intense fights. But visuals are just the surface. To survive in roguelike, the game needs to feel responsive and sound immersive. So I'll pass my word to Ivan, who will tell you about our controls and audio.
In NecroRun, my part of work covered the core gameplay mechanics, everything the player feels every second during the game. I started with the basic movement mechanic. The character is controlled through a character controller, which provides precise control without physical artifacts. The character always rotates in the direction of movement, which creates a sense of natural motion. Next, I implemented the combat system. The attack works through a cone in front of the player, meaning damage is only dealt to enemies the player is facing. The health system is shared between the player and enemies. At 0, the enemy is destroyed and the player loses. When taking damage, the character flashes red, which provides clear visual feedback. One of the most interesting mechanics is the dash system. The player presses space and the character quickly moves forward. During the dash, the player is invincible. This is shown by a color change on the character and a particle effect during the movement. The dash is limited by the stamina system. Each dash costs 25% stamina and a minimum of 25% is required to perform one. Stamina automatically regenerates 2 seconds after the last use. I also developed the gameplay interface. In the top left corner there is a character portrait, health bar and stamina bar with percentage. In the bottom right corner is the collected currency counter. All elements update in real time during gameplay. Also, Roman helped create the portrait variation and implemented the switching logic. There are 3 states: default, excited when the player has 10 or more coins, and low health when HP drops to 20% or below. To enhance the atmosphere, I added post-processing effect to the camera. A vignette darkness the edges of the screen, and film grain adds a grainy texture to the image. Together, these effects give the game a retro PS1 aesthetic and make the world feel more immersive. On the left there is a statue altar. Press E, open the shop and spend coin on upgrades. When hovering over each option, a preview appears. The current value is shown in gray, and what it will become after purchase is shown in green. 4 options are available: health, stamina, damage, and healing. If coins are insufficient or health is already full, the purchase is blocked. I implemented a complete audio system where every action has its own sound. Attack swings and hits on enemies are different sounds. Both sides have multiple attack variations that play randomly, and footsteps cycle through 3 files. You will hear all of this in the action during Yaroslav's gameplay segment at the end of the video. Now I will it over to Artem, who was responsible for the enemy behavior, level generation, and much more.
My name is Artem. I was responsible for the system that makes NecroRun feel like a living, changing world. And I started with the enemy behavior. Each enemy continuously tracks the player and moves towards them at a consistent speed. The movement is smooth and predictable. Enemies never idle when the player is nearby. I also implemented the isometric camera that follows the player at all times. It maintains a fixed viewing angle and moves smoothly without any lag, keeping the player and the arena clearly visible. When an enemy is defeated, it drops between 3 and 7 coins randomly. Only the player can collect them, and the counter updates immediately. I also added breakable pots scattered across the arenas. The player can destroy them using combat mechanics, and they may drop up to 2 additional coins. The level is built from connected rooms, a start room, several enemy areas, and a final outer room. Each room has predefined spawn points for the player and enemies. Enemy positions are randomized each run, so no two playthroughs feel the same. Enemies always spawn away from the entrance so the player has time to react. To keep combat varied, I implemented the 3 enemy types. The heavy enemy is slow, but deals double the damage, and is called red. The fast enemy moves quickly, but hits from half damage and is called green. And the reward enemy is called gold, and drops significantly more coins when defeated. As the player advances through rooms, enemies become stronger. Each clear room increases enemy health by 5 and damage by 2. This scaling makes the auto upgrade feel meaningful and keeps the game challenging throughout. Finally, I implemented the main menu, pause menu, and death screen. The main menu allows starting or exiting the game. During gameplay, the player can pause at any time. When health reaches 0, the death screen appears with options to restart or return to the main menu. All of this system work together to create a structured and progressively challenging experience. Now I pass the word to Yaroslav, who will tell you about the testing and project management.
I'm Yaroslav, and I was responsible for the project management, user stories, and testing. First of all, as a product owner, I wrote user stories for the project, and there are 24 in total. As for the structure, for example, each of them starts with the user card, followed by the acceptance criteria, which has navigation to the feature, functional requirements, successful flow scenario, negative cases, and user experience requirements. Also, some user stories have images attached to them so that the developers could better understand the idea, and subtasks for each user story. As Scrum Master, I assign different members of the team to the user story and the subtasks, set priorities for both of them, and set the number of story points, which were determined during the poker playing sessions and were taken from the Fibonacci numbers. As for the daily meetings, I made a conference space and connected it to Jira. I made documents for each sprint, and they have tables for each working day. In those tables, members of the team could write their name, priority for this day, progress they have made, and problems they have encountered. To develop the game in a team, we made a GitHub repository and which has branches for different user stories, so that the code would be separated from the main branch and wouldn't affect the game if there are some problems. After testing, those branches can be merged with the main branch. And since this repository belongs to Ivan, I forked it so that I could connect it to the Jira project. And as for the testing, I wrote commands to the subtasks that I could test for the bugs and whether they correspond to the acceptance criteria. For example, in the user story currency, there is subtasks after spawning it around the enemy, and there was a problem where coins were launching themselves, which made collecting them harder. So that after the developer moved the subtasks back in the development stage, and after the problem was fixed, they moved it back to the testing. I tested it and wrote the comment that everything works as intended. Also, there was a bug that was discovered later in the development, so I made a task type bug for this one, wrote a description for it, how to replicate it, and added attachments to it with the video and an image. Added and subtasks to fix the bug. And after it was done, I wrote that the comment that the bugs have been resolved. And with that, the demonstration is over. Thank you for your attention.